Assalamualaikum and good morning. My name is Shakina Akmar binti Muhammad Shafri. I'm a postgrad student of Faculty of Electrical Engineering and Technology. Today, I would like to present my product, which is fast prediction of Optimum design for surface-mounted permanent magnet synchronous machine. Firstly, we will go through the product description. As we know, surface-mounted permanent magnet synchronous machine is very popular in industrial application due to the fast dynamic response, high efficiency, and top power density compared to the conventional electrical machine. In order to evaluate the performance of PM machine, numerical methods such as finite element analysis have been intensively used for design and determine the optimum configuration of PM machine. However, FEA require longer computational time to analyze the characteristic of PM machine and lacks the capability of considering multiple objectives for the optimization of PMSM. This new computing framework can provide optimal SM-PMSM design that satisfy multiple objectives in a short time duration, therefore expediting the process of machine design as well as the accuracy of resulting design. The optimal design of 12-slot 8-pole SM-PMSM is further developed by using the combination of subdomain model and genetic algorithm. The optimal design of PM motor demonstrates a reasonable electromagnetic torque as compared with their initial design. The comparison of parameter and motor performances between the initial and the optimal design of 12-slot 8-pole PM machine with the computing framework are validated using finite element model. Thus, the framework of subdomain model and genetic algorithm is verified in reducing the usage of magnet materials and the motor performances of SM-PMSM, which is highly valuable for industrial application. Next, we go to the problem statement. As we noticed from the previous researcher, the influence of two steps is neglected, so that our project will consider the slotting effect and two step in order to predict the motor performances during on-load condition. Other than that, finite element method and optimizer are used to improve the motor performances. However, finite element method is time-consuming, and other optimizers such as PSO is performed poorly in global optimum search, and also surrogate model is less accurate. Next, we go to the invention advantages of this product. A new computing framework is modeled and simulated to provide the optimal design of SM-PMSM. Advantages of fast achievement of the optimal solution, combining subdomain model and genetic algorithm with accurate prediction of performance for SM-PMSM design without trial and error method. Short computation time in determining the optimum design of PMSM. Contribute towards effective and efficient framework in the optimization machine design for various industrial applications. Next, so this is the product specification, which is 12-slot 8-pole PM motor. As we can see that there are several motor dimensions which has been calculated, which are such as thickness magnet, exit active length, air gap thickness, and several of motor radius. This product can be seen in our daily life, such as in refrigerator, printer, air conditioner, fan, and also can be used in medical equipment, office equipment, electric tools, garden equipment, and also beauty apparatus. Next, we will go through the analysis result. This is the initial and optimal result of 12-slot 8-pole SM-PM motor that we obtained from finite element analysis. This first figure shows an initial design which have a full pitch of magnet pull arc and slot opening angle, which are magnet pull arc is 100 electrical degree and slot opening angle is at 5.5 mechanical degree. Has been reduced that can lead the motor become more lighter compared to the initial design. Next, in order to model a new computing framework, several results need to be obtained from the analysis, which include a 3D polynomial equation of curve fitting tools on on-load condition, which require electromagnetic torque ripple and average electromagnetic torque. After we get the 3D polynomial equation, next we need to do some tuning on GA part, which is include crossover and mutation probability, where the minimum best fit for the radial magnetization pattern occur at first generation. Meanwhile, for parallel magnetization pattern occur at 25th generation. This figure shows the comparison between optimum design and initial design of electromagnetic torque during on-load condition in radial magnetization pattern. As we can see from this figure, the magnitude of electromagnetic torque ripple have been reduced, about 74%. Meanwhile, the average electromagnetic torque also have been reduced about 60%. Even the magnet pole out is decreased about 30%, but the decrement of average electromagnetic torque is only occur at 60%. This is because when the magnet pull out is reduced, the average electromagnetic torque is reduced. By reducing the magnet and steel material, it can reduce the cost of implementation so that the PM motor become more lighter. Same as well for the parallel magnetization pattern. The electromagnetic torque ripple has been reduced about 75%. Meanwhile, for the average electromagnetic torque have been reduced about 40%. After we complete the analysis, it showed that the time taken for subdomain model and GA, which is our project, requires only 48 minutes to complete the simulation for 50 iteration. Meanwhile, finite element model takes longer time to complete, which is about 1920 minutes, which is about 32 hours to complete the iteration. Meanwhile, for 300 generation, the subdomain model and GA takes about 1200 minutes to complete the iteration, which is about 20 hour, and 80 hour for the finite element to complete the iteration. This is show that the time taken for the finite element model to complete the iteration is more longer compared to the subdomain model and GA. We can reduce the time about 97.5% by using our new computing framework. So, as a result, the Optimum motor is more efficient and produce less vibration, make it well suitable to be used in high industry application. And the framework of subdomain model and GA is competent in minimizing the usage of magnet material, as well as the ripple in the design of PMSM, which is bring beneficial with lower cost of impose on the motor during the fabrication, and the PM motor become more lighter. We have several commercial potentials such as Eclimo for the electric motorcycle, Dyson for the vacuum and hair dryer, Mitsubishi Moto, Daikin for the air conditioner, BMW for electric vehicles, Rubins, Toyota, Panasonic, and also Siemens. And lastly, this is the list of our publication, and one of them has been invited and published in the Journal of JET 2022 and won the Best Paper Award. So this is my presentation. Thank you.